issue that we've been calling fragility. This is the issue with neural networks, that you can train them on, let's say, images, photographs of people, train a neural network on how to recognize certain faces, and it turns out that if you know what you're doing, you can modify a few pixels in the image, and the neural network will completely misclassify the image. So even though you, the human being looking at it, says it still looks like my mother, the neural network will think it looks like a cat. And clearly this type of ultra-sensitive behavior to small changes in the input is risky. And we'd like to know, what's being done to mitigate that risk and how serious is it. So we don't have answers to all these things right now, but this is an example of a risk. So Professor Rowe is going to tell you about a whole lot of things where there's more examples of risks that we need to be aware of and what his opinions about them are. So please welcome him.
Okay, so you've already heard as we've gone along several things related to risks of AI. Particularly relevant was the talk by Professor Strasser last week where he talked about the ethics of AI, and he pointed out that there were a number of things where you needed an ethics because there could be harms. So I want to talk about what some of those harms are. That's sort of the precursor before you start talking about ethics. So one of the issues that's come up several times is oversimplification, as Professor Denning just talked about. And let's use the example of driverless cars. It certainly is an issue if we're going to put driverless cars on the roads with regular human-driven cars. It's maybe not a problem, though, I should point out, on the battlefield. For instance, in land combat, if you have autonomous vehicles, there's less of a worry that you're going to do something. For instance, you've got a reconnaissance vehicle for land combat. And similarly with drones that are used for reconnaissance, there's not so much an issue with possible harms with them. But when you mix different types of technology at the same time, you can possibly get into harms. And the main thing that people are worried about is rare events that could possibly occur. So here's a driverless car from one particular thing, and the sort of thing that the driverless car would be looking at when it's trying to, let's see. Oh, I guess I can't do anything there. Yeah, sort of thing that the driverless car might see when it analyzes the scene that it's looking at. So one question that's come up, what if, for instance, you see a ball rolling across the road in front of a driverless car? What should the driverless car do? Well, most balls are not usually something that are a serious threat. I mean, something large on the highway in front of a driverless car, it should brake very suddenly, right? And because it doesn't want to hit something large. But a small ball might not be a problem. For instance, if it hits it, it's not going to be too much damage, and the balls aren't terribly valuable anyway. They're not terribly dangerous to the car either. So just seeing a ball rolling across the highway in front of you when you're driving a car should maybe not trigger a braking condition. But of course we know that often balls are associated with children, right? And so if there's a ball rolling across the road, maybe a child's going to chase after it and catch it. So the reasonable thing to do would be to slow down, immediately brake carefully, and be cautious for that. But one of the problems when you're doing things like machine learning with data, you may not have seen this case in your data. It's a relatively rare occurrence. So that's going to be always a problem for AI systems that are based on machine learning. Have they gotten a sufficiently wide range of data? You're going to get often a sampling of the possible situations that a vehicle could see, or a driverless car could see. And does that sampling include a sufficient range of different types of things that could occur? So that you could have an accident, somebody could get hurt, or somebody could get killed. In fact, somebody's been killed with a driverless car, where basically it made some mistakes in trying to recognize a vehicle up in front because it had a white background and a white vehicle, and it couldn't see the vehicle in front of the background. But this is more a strategy issue. How deep do you want your AI system to really understand things? And the same thing's going to come up when you have autonomous lethal weapons. Like, for instance, automated machine guns have been proposed by the South Korean government to put along the border there. I don't know how far they've gotten on implementing them. And of course, they function as a great deterrent against North Korea invading, right? You don't have to have hordes of soldiers watching every instant of the border. You can have lots of these automated systems that just fire if anything comes across the border that looks like a human being. But of course, what do you do about a defector? If somebody actually wants to defect from North Korea, it's going to be hard to distinguish them from a small North Korean military force coming across the border. So, you know, that's something human sentries could make judgment call, and it's going to be hard for an AI system to learn that. Of course, what you can do is try to supplement an AI system with some expert knowledge. There could be things that an expert could come along and add to an AI system afterwards. But if we try to do this totally autonomously, we can get into trouble. This issue also arises with drones, definitely, because drones have limited knowledge of what they're what they're viewing overhead. And so if you try to put lethal force on drones, you run into lots of difficult issues of trying to be sure what you're firing at. So, oversimplification is what I'd call this. You've got a model that maybe you've trained it or maybe you've used human experts, but you may miss some key things that you need to know to do the activity, and those could cause harms. Those things that you're missing, things that people might know, but the AI system might not know. So sometimes these can occur because of financial pressures. So if you hire a contractor to build a automated machine gun system, they want to make money on their contract. So if they spend a lot of time worrying about every little thing that could occur, very rarely, they're not going to make as much money. So there's a commercial incentive to cut corners. Now, if you're doing this with a government, they could cut corners, but of course they have contracts too. And so they could say they're not going to cut corners, but still do so. So there's a lot of difficult issues relating to oversimplification of AI systems. And these often relate to ethics. You have to decide whether it's ethical to field a system that hasn't been fully cognizant of the sorts of things that can occur. Here's the famous stop sign example. I don't recall if you've seen this one before, but this is an interesting example where people were trying to fool a vision system for an autonomous vehicle into confusing a stop sign with a speed limit 45 sign. And so they showed that the system was using training based on a convolutional neural network. That if they put stickers in the right place on the stop sign, it would cause it to be confused between the stop sign and the speed limit 45 sign. So that's very bad because that means a car could maybe not stop when it comes to a stop sign or do something like that. Now, how did they do this? They basically did lots and lots of experiments with pictures of stop signs where they made digital changes to the picture of the stop sign to see if that would fool the neural net, the convolutional neural net that was doing this. And so they experimented quite a lot. But, and you could argue, well, these were then trying to find really weird cases that wouldn't occur in the real world. But the idea is an adversary could maybe do this too. If an adversary wants to fool your AI, they could try to construct artificial images by experimenting lots and lots of times to see which things could fool a standard neural net. And this problem is exacerbated by the fact that there are a lot of standard databases of images used for training AI systems. There's a lot of attempts to try to use the same databases for training things. The reason for that is you can compare performance of different algorithms really well. That's important for AI researchers to be able to compare performance. So when people use the same databases, somebody could try to game that database, could try to find ways that that particular set of images could lead to a mistaken conclusion. So anyway, the people doing this did basically digital modifications of these pictures of stop signs. And then once they figured out some good ways to modify stop signs, they went out and actually put stickers on stop signs in the real world to see if that would fool things. And it worked just as well if you actually put real stickers in the real world, which was quite surprising. Now, of course, we have a better way of recognizing those are stop signs. We know that they're supposed to be red octagons. So in part, this was a demonstration of a weakness of most convolutional neural networks, is that they tend to focus in the lower layers, the deeper layers on little picky details of the pictures that they're being trained on, little small areas of the picture and characteristics. And they don't look at the larger whole, the fact that this is a red octagon, except at some of the higher layers. And sometimes they don't get to that because they find other statistical tests that are maybe they think are better for doing stuff. But so clearly, the way you solve this is you must have some inputs to this system that says I'm looking at something red and I'm looking at something that's an octagon. If you have those two inputs, the neural net's going to do much better. But just using the traditional convolutional neural network method was part of the weakness here. So that's one way you can avoid harms of AI systems. Maybe have more than one method for doing your machine learning, or maybe insist on having a diversity of methods run simultaneously on a situation and then take a majority vote of what they say. So if, for instance, something weird happens like here, it doesn't recognize the stop sign, a majority vote using some other AI methods might find that it was a stop sign. So next issue that's related to that is you may have bugs in AI software that will cause harms to people. And of course, all kinds of software can have bugs. In some ways, AI software has more problems because of two things. It's complex and it's often probabilistic. It's complex, as you've seen by several of the talks here, because there's just got to be a lot of details in many cases to get a intelligent functionality in a software system. So in particular, some of these systems have billions and billions of data items that are being used to justify what they're doing. So they can be complex just in the sense of the amount of data. They can also be probabilistic. Now that means that several of the algorithms, like neural nets, depend on probabilities that something is associated with something else. And you can use that sort of thing, you need to use that sort of thing when you've got problems in which there's no clear policy, but you want to find the best policy for something. And so you've got to rate things by numbers or likelihoods of success and things like that. So a lot of these AI algorithms are going to have probabilities, but when you have a system with probabilities in it, often its behavior is hard to predict. And so it's hard to test and how to debug the system, because it'll do things unexpectedly or differently. In fact, doing things unexpectedly is good for some AI algorithms try to do unexpected things, like if they're trying to find a battle plan for a situation that occurs in a military conflict situation. It might be good to be creative and come up with unexpected things. So you're going to have some more degree of uncertainty about AI software than with other types of software. Though there are certainly exceptions for some types of software that use probabilities like stochastic algorithms and things like that. So neural nets are going to have both these weaknesses. They're going to be complex, or at least the training of them is going to be complex. And they're also going to use probabilities all over the place in the neural net. So anyway, it's important to emphasize that when there are bugs in software, people can die and get hurt. There's a famous example from the early years of computer science where somebody programmed an X-ray machine incorrectly so that the loop didn't terminate. And so people were getting 100 or 1,000 times the dosage of an X-ray because of a simple programming bug. So there's lots and lots of ways in which people get hurt by an AI system, even something as benign as a diagnostic tool like an X-ray. Now, Professor Strasser talked about moral responsibility for AI harms last week. And that's an important issue. But also, of course, there's legal responsibility in our society where everybody likes to sue one another. Legal responsibility is often an important issue with some of these harms too. And so people have been gradually building up some case law that relates to legal responsibility for flaws in software and bugs in software. And indeed, authors of software can be liable, in some cases criminally liable, for the bugs that they find in the software. Of course, part of this is the explanation problem we've talked about a few times before, that if AI can't explain itself, that makes it difficult to find the bugs. And so that's A key weakness I've mentioned before with neural nets, they tend to be poor at explaining themselves and why they come up with the conclusion. That's not what they're designed for. They're basically designed to learn associations between input and output and not the reasons for doing that. However, there are other methods in AI that do explain themselves very well, and that's one advantage of rule-based systems. Rule-based systems tend to be easy to track how they reached a conclusion and easy to be able to go back and examine the steps in which they reached a conclusion. So there's a lot of good arguments for using rule-based systems with if-then rules and Boolean algebra and things that are either true or false as opposed to probabilities. Of course, another problem with AI is that an adversary could insert bugs into it. So if an adversary changes some AI software, it could cause quite a lot of harm, and it could be something that, because AI software is hard to debug, could be something that nobody would notice. Now, another harm is that it's hard to blame people with AI. This is true of a number of automation techniques, but it's also true with AI in particular, because it's hard to see oftentimes how much is the responsibility of the programmers that initiated or the people that did it, or how much is the responsibility of AI software. And Professor Strasser also talked about this last week. So that may lead to either of two extremes. People may unfairly blame the AI for some bad outcome, or they may unfairly blame the humans that are responsible for implementing the AI. I'm more worried about the first one, though, because oftentimes people have set in motion the methods that are being used by the AI, and the AI implementation just takes advantage of what people have specified for it to do. And so it's really the human responsibility there that leads to bad results with the AI. But anyway, whoever's blame it is, when it's unclear about the assignment of blame, often this increases incompetence in organizations. So organizations aren't doing what they're supposed to do. They can't find their problems and fix them. They're not getting the proper feedback they know to how to fix them and to actually go about fixing them. But this problem occurs with lots of areas of software. Oftentimes it's hard to figure out. We can't just blame the software, and we can't just blame the people responsible for it, but it's a combination of the two. Again, good explanation facilities will help to assign the blame. Now, one other interesting kind of risk is that machine learning may disappoint us eventually, because humans like to see patterns. And so the hope was, when we started doing machine learning, AI systems would be able to see all kinds of great patterns that nobody had seen before. But humans do have a tendency to see patterns where none exist. So we have things like gambling, for instance, conspiracy theories, and supernatural phenomena. Here's a famous ghost picture here on the bottom. Somebody claimed that that was a real ghost there. So, but people tend to find lots of things to put together and get patterns. So for instance, in my house, there's a lot of creaking sounds. So my wife thinks that there's a ghost because there's no obvious other explanation why there's so much creaking all the time. Well, it is a wood frame house. So, wood frame houses tend to creak in the wind and things like that. But anyway, so we run these AI systems. People may find out it's not discovering the patterns that people are too easy to see in things, and it may disappoint people, and people may be turned off against AI because of that. We'll see. Related issue, AI may not know all the human needs that are possible. So we've already talked about this, that the driverless cars issue. As I say, AI is trying to create obedient servants. So it should think of primary needs of humans, what humans are needing to have some priorities about. That was the idea behind Isaac Asimov's laws of robotics, to try to have some ethical principles that would inform all robots. But the main problem is there's lots of surprises that can occur with human needs. And so, for instance, you may have an AI system that's trying to be a roadside assistant or something like that, but what does it do in an emergency or some unusual kind of emergency that it hasn't been programmed for? Now, there are other areas of AI that can help with this type of problem. So for instance, if you've got a neural net that's trying to decide how to control a driverless car, and some unexpected thing happens on the road, like all of a sudden there's a big object on the road and it's going to have to drive around it. There is an area of AI which we have not covered in the lectures here called planning, and it's quite a large area of AI which deals with trying to come up with a sequence of events to solve some particular problem in the real world. So what you should need to do for the driverless car in that case, where there's some unexpected obstacle, is do some real planning. You've got to have some integration with that type of thing. But if you don't have that, if you haven't anticipated you might need to do some planning and haven't figured out a good way to implement it, you may have some harms due to that. But I think that's going to be one of the best ways to address the unexpected needs problem. Now, a lot of this literature on harms of AI is focused on automation. So AI is a kind of automation, and you've heard about that several times in the lectures here. Here's some nice robots in a factory, right, doing all sorts of cool stuff there. So one of the problems with any form of automation is that you're going to get unemployment. Well, we've seen this thing because automation has been going on for quite a long time. You recall Henry Ford in the 1920s started automating his assembly line, and that was a big advance, allowed him to make his cars quite cheap. And that was really led the industry and encouraged a lot of automation. And so automation continued to really picked up pace in the 50s when we started getting digital technology, and it's picked up further pace. But a lot of that earlier automation has been what people call blue-collar automation, for people that do physical labor and of various sorts. And you can design robots, particularly on an assembly line where they don't have to move back and forth, they can just stay in one place. You can design robots pretty efficiently when they don't have to move a lot and have just sort of repetitive tasks to do. So that automation has gotten rid of a lot of blue-collar people. There was a really good show on Nova recently, or no, was it Frontline recently, where they talked about AI. And they was pointing out, had some experts there pointing out that's the reason for the decline of the American industrial base to a large extent. Not that jobs are all going to other countries, but that we can do things efficiently here by automation, and automation has reduced the number of people in factories considerably. Well, AI is a kind of automation, and you've probably seen from this course that it's going to automate white-collar jobs. A lot of the things we're talking about are decision making and viewing things and making decisions about what you view, hearing things and making decisions about what you hear, analyzing signals and things like that. So all these things are traditionally white-collar jobs. And so we're going to get unemployment now with white-collar stuff. In fact, the remaining blue-collar people are still going to be pretty much in demand, because you're still going to need people to work on your car. For instance, they're actually going to have to unscrew things in your car. It's going to be hard to automate all that sort of stuff. So blue-collar jobs are actually in pretty good shape now. It's white-collar jobs that are going to create problems. So what happened with many blue-collar automations is that the people were retrained and got white-collar positions. But now, where are the people that are being eliminated by white-collar automation going? There's not an obvious solution for that. So we're bound to see some unemployment increases coming up in the future with this AI technology. It's true sometimes new jobs are created. We'll see. But you know, the part of the thing was that a lot of these decision-making things are being automated, and there's not really another decision-making thing that people could do. So some people have speculated we may end up with a society where most people are living on government support because everybody is unemployed. And that can have bad consequences for a society where a lot of people are not doing meaningful work. It creates social unrest, creates bored people for one thing, and social unrest can lead to all sorts of interesting consequences that societies generally don't benefit from. So another issue, possible harm, is the inequality in society. So usually when any technology is introduced, the people that can take advantage of it first are the rich people. And this has happened with lots of different technologies. For instance, with automobiles, right? At first only rich people could afford to buy cars. And so they had access to the greater mobility that you got with a car that poor people didn't. and could take advantages in society. And that gave them ability to travel more and do all sorts of interesting things in the early 20th century. But as you saw what happened, eventually cars got cheaper, and eventually everybody was able to buy a car, or most people were able to buy cars. And so things tended to balance in the long run with the technologies. The technology diffused. Some technologies are not easy to make cheaper, but other technologies, will get cheaper. For instance, digital technology, as you see, takes advantage of mass producing many quantities of that. So that's the reason a lot of prices have gone down so much with digital technology, is that when you start getting large quantities and you start debugging it thoroughly, you can manufacture something really quite cheaply. But anyway, so will this happen with AI? Will AI temporarily increase inequality in society? So that's probably likely to occur. AI can be used, for instance, to plan things, like plan a vacation, for instance, or plan your work activities so you're more efficient in the office and things like that. Can affect personal lives too. So probably it's going to have an impact on disproportionately on rich people, rich and powerful people, I should say. So, question about a lot of technologies is how long will it take to disperse? And so you see some people from Africa here. How long is it going to take technology to get to Africa? Well, there actually are some interesting results from Africa with cell phones, because they've always had problems with having landlines and telephone connections. Cell phones have turned out to be very effective in Africa, because the infrastructure you need for them, of these towers, does not have to be run underground or through power lines and stuff like that. And so that's one technology that's really done well in Africa, and a lot of people didn't predict that when the cell phone technology came out. So we may have some things like that with AI, where AI is particularly good with particular problems of poorer countries, like, for instance, medical information oftentimes is not disseminated properly in poorer countries. It may be possible with AI technology to be able to target things better to particular audiences for particular medical problems. So we'll have to see. But of course, if it takes too long for technology to disperse, are people willing to wait? So in the meantime, when people feel that they're really at a disadvantage, there may be unrest based on that. Now, one other interesting thing I want to mention related to this is the European Union has a law about AI. It's actual law that says that you can't use AI where you increase inequality deliberately. And what they were thinking of was mortgages and stuff like that, where you award mortgages maybe based on an AI algorithm. So the sort of issue would be, for instance, there's a bunch of correlations with how much somebody is going to pay back their loan. And for instance, their socioeconomic income and things like that could be one of the determiners, but that's also based on race in many countries. And so race is actually correlated to some degree with the extent to pay back a loan. So the European Union didn't like that and said that it was unfair to do that sort of thing, and they wanted people to publish their algorithms that they were using to make decisions like this that affect people. So we'll see what happens with that in the future. But anyway, I think a law is probably a poor way to try to address this problem of fairness. You can try and legislate these things, but there's so many subtle things that an AI system could have a bias about that trying to legislate those out of existence seems difficult. Now, of course, one harm that everybody's worried about is violating privacy of people with AI. And we've seen in this course, you can combine information in various ways to say something about a person, what they're doing, and what sort of activity they're involved. And intelligence communities are really interested in that for finding terrorists, for instance, trying to figure out who's a terrorist and who's not. And to do that, construct networks and things like that. So turns out there often, when you bring enough data together, you can use subtle clues to classify people. So there's a famous example where Google was able to determine that a teenage girl was pregnant before her parents knew it, because she was asking particular queries online to the Google search engine. And so the question is, could your queries to Google reveal certain other private details of your personal life? It's hard to anticipate all the personal details that you could possibly get out and how they might be related to the queries you're doing online. Just so difficult because there's so many tenuous connections that these sorts of things could actually hurt you in the long run. So for that reason, it's important, I think, to have some laws on privacy and what sort of data is available. But also you could have some laws that relate to trying to use AI to try to make some decisions about combining all that information. Of course, I should point out that tracking people has become easier with AI software. You can use clues to figure out where somebody is, and that's been used for tracking terrorists, for instance. But of course, this same technology could be used to track you. Now, why would somebody want to track you? I assume we're all innocent people here that are not engaged in any criminal enterprises, but intelligence agencies would love to know where U.S. military people are. There are lots of different things they can do once they know where U.S. military people are. They try to get people next to them and see if they can steal some secrets from them, things like that. Or they even may want to assassinate you. So there's a lot of different things that could, the reasons why tracking information could be a problem because of the AI abilities that we've got now to combine all the clues to where you might be. So this relates to the issue of totalitarianism. So as Professor Hundley was saying on Monday, China is really big on AI right now. I went to this conference a few weeks ago, and it was scary. It was an AI conference, and normally this conference gets 400 submissions a year to the conference, and they present maybe 100 papers. Well, this year they got 1,500 submissions. Most of that excess was all from China. So, and it's an AI conference. It's about applied AI. It's called Tools for AI. And so there was a ton of Chinese stuff there, and it was scary, all the stuff that they were working on. Lots of stuff related to government surveillance of their own citizens and things like that, as you'd expect. Also, all sorts of different things. So it's clear they're making a real push on doing this. And of course, the fact that you can track people really easily with AI, or it helps you track people anyway. It makes it good for bad governments. Also, you can tell what they're doing. You can use clues to what people are up to and things like that. So it's tempting for bad governments to try to use AI. China and Russia both like AI, there's no question about that. And they can use that to stifle dissent. But what I've also been interested in is that we now have a lot of monopolies in the software business. So we have Google, Microsoft, Facebook, and Amazon, which are virtual monopolies, if not outright monopolies. And so we're seeing increasing activities, sort of like a totalitarian government, of trying to force people to do various things with their activities. They pretend to be benign. In most cases they're benign, but oftentimes they're doing things like forcing you to buy their products and stuff like that. So once you buy one Microsoft product, you have to buy other Microsoft products and stuff like that. So I'm worried a little bit about corporate fascism. There's been a number of articles written recently about how fascism is on the rise in the world, and we're starting to see governments that are more and more fascistic. So I'm worried that maybe large corporations are getting some of the characteristics of those types of things there. Okay, so that's all I had to say.